In this video, we are going to look at methods for finding limits, and we're going to focus on the graphical approach. Okay. So recall that the graphical approach to finding limits is that we are going to take a graph of the function and look at what happens to a function value as we take one x value approaching another. And we're going to look at this kind of visually. Okay. So in our first example, we're going to look at f of x equaling x minus 1 quantity squared. And we want to find the limits as x approaches 2. So here, the first thing we want to do is get the graph of a function. And so because this one is a parabola, we know what the graph is going to look like. And again, if you don't, this is an easy enough one that you can plot some points or find the vertex and do some of those other methods to find your graph for this. Okay, so first we'll label our graph. We can see at 0 we're going to have a value of 1. At 1 we'll be at 0. 2 will be back at 1. 3 we're going to be up here at 4. 4 we will be up here at 9. Okay, and so for this parabola, there's kind of the sketch that we're going to need. And I didn't worry about graphing the left-hand side of this graph, and that's because we're looking at x equals 2. So we want to take values that are close to 2 and figure out what it's doing. Okay? And so here, if we look on our graph, we can see that from the right side of 2, if I'm coming in from the right direction, then the graph is going to decrease down towards a value. And if I come in from the left, it's going to increase towards a value. And as I get closer and closer to x equal 2, that we can see that the y values are getting closer and closer to 1. So here we can say that the limit as x goes to 2 of x minus 1 quantity squared is going to equal 1. Let's look at another example. So in this example, we've got another polynomial function. F of x is equal to 2 times the quantity x plus 1 cubed plus 3. Okay. So again, we're going to begin by graphing our function. Okay. So just like before, we can graph this. So at 0, we can see we're going to get a value of 5. At negative 1, we're going to get a value of 3. At negative 2, we get a value of 1. And then from there, we can plot a couple more points. So at negative 3, we're going to be way down there. At positive 1, we're going to be way up above 10. Okay, so there's a sketch of our graph. Okay, so now we want to look at the limit as x approaches negative 1. And so again, the idea is we're going to come in from the both sides and see what the function value is approaching as we do this. And so from the right-hand side, again, if I come in from the right, we can see that the function value is going to decrease to a particular point. And if I come in from the left, we can see that the function value is going to increase. And so as I get closer and closer to 1, those y values are getting closer and closer to 3. So again, we can talk about the limit by saying the limit as x goes to negative 1 of the quantity 2x plus 1 cubed plus 3 is going to equal 3. So let's look at this trig function. Okay, so f of x equaling 3 minus 4 cosine of x. And let's say we want to find the limit as x goes to pi over 2. Okay? So again, we're going to start by graphing this function. So for cosine of 2x, we know that the period for that is going to be pi. We have that the amplitude is going to be 4. We're reflecting it. Okay? And then we're going to shift it up 3 units. So when x is 0, we are looking at -1. When x is pi over 2, which means we're looking at 7. Would be there. When x is pi, we're back to -1, and there's 1 full period. If we want to find kind of the 0 points, you can look at pi over 4 and see that kind of the midpoints of these is going to be at 3. So here's 1 full period of our function. There's the second full period. So there's the graph of that function. Now again, we want to find the limit as x goes to pi over 2. So there's our pi over 2. Same as with the polynomials, we want to come in from both sides and see what the function value is doing. So here it's a little easier to see. As I come in from the right, my function value is increasing. As I come in from the left, again my function value is increasing. In this case, both sides are going to this high point up here, which happens to be at 7. So this says that our limit, as x approaches pi over 2, of 3 minus 4 cosine of 2x is going to equal 7. In some cases, you are not going to be asked to find the limit from just being given the function. In some cases, you're going to get the graph ahead of time and be asked to find the limits the same as you would with the function. So for example, in this case, here's our graph of f of x, and we want to find some particular limits. So let's look at the limit as x approaches 3 of f of x. And let's look at the limit as x approaches 0 of f of x. And we're going to look at another notion to start out, the limit as x goes to infinity. So again, for 3, this is just like the ones we had with our functions that were given, the algebraic form. Once we graphed it, we could just find the x value we're looking for and approach from both sides to see what the limit's doing. So in this case, if I'm looking at 3, I can see if I come in from the left, it's going to go decrease down to a point, and if I come in from the right, it's going to increase to a point, and in this case, that point just happens to be 0. So our limit as x goes to 3 of f of x is just 0. If I'm looking at x going to 0, we can see that something different happens. Okay? So as x goes to 0, my function kind of breaks. I have 2 different things happening. If I come in from the left, I can see that my function values are going to approach 2. But if I come in from the left, I can see that the function values are going to decrease down to -2. And so here, this is going to actually kind of spark some new ideas. And that is the notion of a one-sided limit. Okay? So here, if I look at the limit as x approaches 0 from the negative side of f of x, like we said, we can see that the value becomes 2. Okay? So this is what we call the left-hand limit of a function, or the limit as it approaches from the left. On the other side, if we look at as x approaches from the right, we see that the value is going to go to -2. So we get that the limit as x goes to 0 from the positive side of f of x is equal to -2. And again, this is what we call the right-hand limit. And one of the things to notice is, obviously, if I come in from both sides and the values are different, or they're approaching different things, then the two-sided limit cannot exist. And so we actually say the limit as x goes to 0 of f of x does not exist. So D and E. And that's because, again, if I come in from the right and from the left, I'm getting two different values. And then the last one we wrote up here was if we look at the limit as x goes to infinity. And so here, this is just like what it sounds like. If my x's go off more and more positive and just keep going out, where do the function values eventually end up? And so here we can see we are now looking as x gets further away from the origin. So if I go in that direction, then our y values tend to decrease. And they're going to keep decreasing. At least that's what our function looks like it's saying it does. So here, we would say our limit is -infinity. Okay? And we can look at different values on this graph and determine the limits. Both the one-sided limits and the two-sided limits. Okay? So for example, if we look at the limit as x approaches -2 from the left, we can see coming in from the left, the function is decreasing and the values are getting closer and closer to -1. If we look at the limit as x goes to -2 from the right, well, coming in from the right side, our function value towards -2 is just going to keep increasing. Okay? And so here we would say that that limit is +infinity. And again, once we have the two one-sided limits, whether they're actual numbers or infinite, we just need to determine whether or not they are equivalent to determine the two-sided limit. So in this case, if we look at the limit as x goes to -2, this tells us it does not exist.